Well, I am doing the third little video of today. I'm trying to keep each one short so you can listen to it in between all the other things you do. Nucleophilic substitution. What we need here is we need a leaving group, and remember, what is a leaving group? It's something that leaves. And it's something that can be stable after it's left the alkyl halide. And we need a nucleophile. Remember, this one's cyanide. It'll kill you. So we need a nucleophile. And the nucleophilic substitution happens when the nucleophile comes in and kicks off the leaving group. Right? It sounds very, very simple. So here's our product, the same carbon framework, and now we have our nucleophile and a byproduct, which has fallen off the screen. Okay, it sounds simple enough, as I said. But once again, we have different kinds of alkyl halides and they behave differently. And just like we have E1 and E2 elimination, we have SN1 and SN2 substitution. So the overall reaction looks as I've just shown you. But what if I have a tertiary alkyl halide? Well, then I'm going to have an SN1, and this is how we write it, SN1 mechanism. Well, what does that look like? You probably already guessed it. With the SN1 mechanism, there is only one molecule involved in the slow step, and that molecule is the alkyl halide, and so we get are you guessing? Your alkyl halide, sorry, your carbocation. The carbocation is now going to be attracted to the nucleophile. And so we have our nucleophile. Let's imagine we have an OH minus. Now you know that's a base. It can also be a nucleophile. And yes, you are calculating correctly that we're going to have a problem. We're going to have a clash of mechanisms. Okay, so now the nucleophile can then just attack or attach itself off screen to the electrophile, which is the carbocation. What do we know about this? It's flat. So it has, I'm going to try and draw it for you as flat, and it's got a p orbital. So which side is the nucleophile going to attack? It can attack on the top, or it can attack on the bottom. Because, and yes, I can see I'm off the camera, because it's a p orbital. It's flat. It's equally accessible from the top and the bottom. So the product is going to be a racemic mixture. In this case, it's achiral. But in some cases, it's not going to be achiral. Okay, so the SN1, it has the same profile as the SN1 we had before. Same energy profile as E1. 2 steps, 1 molecule, and a carbocation in between. Okay, so let's have a look at SN2 in the next video. Okay, we're going to have a look at the SN2 mechanism in this video.